In this video, we will learn how to calculate percentile, but first, we must know what percentile is. At the beginning of this video, a brief definition and a short real-life example of percentile will be given. What is a percentile? A percentile is a measure of relative standing. It is a descriptive measure of the relationship of a measurement to the rest of the data. In statistics, a percentile is a term used to express how a score compares to other scores in the same set. It is typically defined as the percentage of values that fall below a particular point in the distribution. For example, in your class, there are 50 students. You ask your teacher about your final grade in her subject, but your teacher did not answer directly. She just said that you're in the 75th percentile in your class. At first, you got disappointed because you thought that your grade was 75. After the class, you approach your teacher and asks her if your grade was 75. She explains that the 75th percentile does not mean 75 in your marks. She further explains that it means your grade is above 75% of your classmates. So you compute it, and found out that it was higher than almost 38 of your classmates. So, how do we calculate percentile? There are many ways on how to calculate percentile, depending on what the problem is. Let's have this example. Suppose your section is taking a final exam. After the exam, your teacher told you about your score, and you're in the 95th percentile in your class, with a mean of 40 points, and a standard deviation of 3. What is your score if you're in the 95th percentile? In this example, we must find the value or score that corresponds to the 95th percentile. The 95th percentile is the score that holds 95% of the scores below it, and 5% above it. For better understanding, we can look at this illustration. To solve this problem, we must follow these steps. First, we must express the given percentage as a probability. Here, the given percentage is z, equals 95%. In probability, this is 0.9500. Second is to find the area under the normal curve closest to the probability of 0.9500. Since there is no exact value of 0.9500 in the z-table, we will find the value closest to it. Here, 0.9495 and 0.9505 are the closest value to 0.9500. The third step is we must find the value of z, in the z-table. 0.495 and 0.505 correspond to the z-values of 1.64 and 1.65. We cannot have these two z-values. Now what we will do? In most cases, between the two numbers, we shall choose the number closer to it. But in this case, both the probability that corresponds to 1.64 and 1.65 have a 0.0005 difference in 0.9500, which means we cannot choose between the two. What are we going to do now? Here comes the thing called quick maths. Let's just add 1.64 and 1.65 and then divide it by 2. Now we have 1.645. Now we shall move on to the fourth step, which is solving for x. In this step, we must use this formula, z equals x minus mean, over the standard deviation. Now, let's solve. Substitute the given we have to this formula. Z is 1.645, equal to x minus 40, over 3. To eliminate the denominator on the other side of the equation, we must multiply both sides by the number in the denominator, which is now 3. 3 times 1.645 is 4.935. X minus 40 over 3, multiply by 3 is, x minus 40, we'll cancel the 3. Now we must equate this equation to find the value of x. We'll transpose 40 to the other side to isolate x. Add 40 to 4.935 and we'll get 44.935. Since we're looking for a score in an exam, we can round off this by the nearest whole number and we'll get 45, but this is not necessarily needed, it's on a case-to-case basis. The last step is to make a statement, to describe and clarify the answer. Now we know that the score corresponding to the 95th percentile is 45 points. This means that 95% of the scores are below 45, and 5% of them is above 45. Now, let's have another example. Suppose you and your friends are in an amusement park, and you all agreed to play a shooting game. Other people are playing during that time, and you can see their rank on a leaderboard. Now, it's your turn to play. You did your best while playing the game, and in the end, you see in the leaderboard that you beat 67% of the players. Suppose the scores on the leaderboard have a mean of 150 points and a standard deviation of 50. What score did you get at the end of the game? For this example, we will just repeat the same steps that we did on the first problem. In this one, we will illustrate first the appropriate normal curve to clearly visualize the percentile of our score. Second is expressing the given percentage as a probability. So, 67% is 0.6700. The third step is to look for the value of z that has a probability of 0.6700. So in the z table, 0.6700 corresponds to 0.44. The fourth step is solving. We'll substitute the given values to our formula. Z is 0.6700 equals x minus 150 over 50. We'll eliminate the denominator by multiplying both sides by 50. 0.6700 times 50 is 33.5, equals to x minus 150. Then we'll transpose negative 150 to the other side to isolate x, and just add the two numbers and we'll get 183.5. The last step is to describe our normal curve illustrated at the beginning of this process. Now we know that 67% of the people that play that night score below 183.5 points, and 33% of them score above 183.5.